try at seeing how to do the composite curve, dia memang sangat simple. It's not as hard as your heat punya composite curve because you actually have to do your hot composite curve, your cold composite curve. So yang ni kita boleh terus plot. The only difference is you have to shift it, which takes which macam yang tu je lah kot yang I think is confusing. But if you get it, then it'll be easy lah. So today it's going to be the water cascade. So significance of this pinch region. So macam heat, kita ada pinch region. And I think this is something that I would like to say lah. Sebab rasa macam dalam assignment pun ramai orang salah. And dalam MTA pun. So kalau untuk composite curve, if this graph is like this, ya Allah, horrible ni graph. Tapi kalau graph dia macam ni, dia sebenarnya kena menurun lah. Kalau this graph is macam ni, this one is QH min. Yang ni QC min ke QH min? Tiba nak tanya.
QH min.
QH min. Okay, thank you Azrai. So always look at what needs to be done. So kalau macam ni, kita perlu heat up. Okay. And so kalau kat bawah ni, we need to heat up it as well. So dia akan jadi QH min. So basically dua ni tambah, basically dia akan jadi QH lah sebenarnya. So QH1 plus QH2, dia akan jadi QH min. So this is usually the cases of threshold problem. So macam kita kena tahulah. So kalau dia macam ni, maksudnya this region and this region kena cool down. So both of this is QC. So it's important to know. Sebab I think ramai yang dah buat betul lah. But then sayangnya sebab confusion. So then you know lah, we know what needs to be done. So these streams kat sini, what needs to be done is it requires cooling. That's why it becomes QC. But anyway, putting that aside, sorry, selingan pula. Basically kalau untuk heat or heat punya pinch, kita tahu, sorry, macam ni. Kita tahu, terbalik. Selalu. For heat punya, kita tahu yang kita perlu, so above pinch, we would require your heating. Okay, and below pinch, we would require your cooling. So QC min. Kalau untuk water pinch, above your pinch, you would require fresh water. So it requires clean water. So sebab apa? Sebab kita kena ingat balik graph So this one, the graph is temperature times enthalpy. So kalau water pinch, the graph will always be apa? Siapa ingat?
Water source dengan water sink ke doktor?
Okay, so atas dia water source and water sink. So it depends dia punya flow ni. Tapi yang kat sini kita ada mass load and concentration kan? Flow rate, yes. So mass load and flow rate. So bila kita dapat dekat sini, when we have a pinch region kat sini, so sebenarnya dia akan sentuh Dia, okay saya tak ada lukis sangat. Tapi basically you would have kat bawah ni, meaning the mass load is very low. Therefore, it would require cleaning. Whereas dekat atas ni, terbalik je. Whereas kalau above pinch, it requires fresh water and it could you basically controls your overall target punya flow rate. And kalau it's below pinch, you have to make sure that your wastewater sources is supplied to your demand and dia punya total mass surplus is more than your total mass load deficit. So nak katanya you actually have more water to be clean rather than having to supply your fresh water. So itu in terms of water. So we're talking about the dirtiness and the cleanliness of the water lah compared to whether we require heat or cooling kan. So sebab tu dia you just play around the graph kan. So basically the significance of the pinch is that it's obviously the most constrained part of the process. So dia akan located at that pinch causing source. So where there is drastic changes in your plant ataupun your water network. So it changes from your source to it changes from the source to becoming below a demand so that deficit kan. So macam sama juga kalau sebelum ni kita ada excess of heat above your pinch, it goes to requiring cooling. And then part of the source at the pinch is included in the region above pinch, and it also belongs to the region below it. Basically apa yang ni nak cuba cakap is that and this relates to this one here, is that you can basically not transfer anything across your pinch lah, similar to your heat punya. So yeah, you can read more about this later because I don't want to read the slides, but basically the understanding is similar to that in heat integration. Okay. So this second part, which is water cascade, is going to do the same thing as what our water CC does. So kalau kita tengok water targeting, apa dua benda yang kita dah dapat? What is the output that we need? Kalau energy, kita perlukan QH min and QC min, and maybe your T pinch, Q recovery. Kalau water targeting, baru belajar last week. Tak ingat ke?
Fresh water dengan
Fresh water dan wastewater.
Betul. So fluoride fresh water dengan fluoride wastewater. So apa banyak air yang kita perlu bersihkan, which is the wastewater, and berapa banyak air bersih yang kita perlu supply. So this is the two things that we need. So we're gonna get the same thing when we do water cascade. So steps ni sama, probably a bit less compared to kita punya composite curve, but yang bestnya pasal water cascade ni is easy to use in Excel lah. So nanti you can just easily calculate it in put it in table. So dia ada banyak-banyak pun you boleh calculate it together. So this first step is the same. This first two step is the same. Tapi yang 3, 4, 5 ni yang baru. So we're looking at the same example. So semua dah faham ke example ni?
Belum.
Apa yang tak faham? So dia tanya soalan sama, pinch point, fresh water, wastewater using water cascade. So nampak tak macam mana yang technical constraints ni faham tak? Kita tengok last week. What is the flow rate of wash feed? Minimum, maximum. What is the maximum concentration of NH3? Berapa banyak particles can be in your boiler feed water. Ni semua ingat kan daripada last week? Yes, no? Tak ingat sangat? Confused? Okay lah, let's ask questions yang kita mungkin boleh jawab kan. Mungkin, saya yakin boleh, you guys boleh jawab kan. So, mana water source dan mana water demand dia? Mana water demand? Baru je tengok last week.
boiler dengan scrubber.
Boiler dengan scrubber. So here dengan here. Okay, betul. Ada lain tak?
Tak ada dah.
Tak ada kan? Okay, so water demand is basically which of the equipment yang memerlukan water for it to function. So you need water for the boiler to boil it into steam, and you need water for the scrubber to clean your gases kan. Okay, what about your water sources? Baru buat last week. Okay ke semua?
Ada 4 kan doktor?
Okay, mana?
Off gas condensate, aqueous layer. Lepas tu dekat bottom tu dengan condensate.
Okay, betul. So it's usually if we still don't know where to find the water source, look at your wastewater. So dia adalah daripada kita punya wastewater. So 1, 2, 3, 4. So kenapa dia jadi source is because you can clean it or you can either supply it or recycle it back to your water demand. So that is your water source. Okay. Semua okay ke kat sini? Lepas tu macam mana kita dapat this table? Okay ke?
Okay, Doktor.
Okay alright cool. So kita boleh dapat flow rate and concentration daripada these values here. So kalau tak okay boleh you can let me know sebab kalau nanti tak tahu kan susah kan. So kita boleh dapat these values sama daripada sini. So this one, this one, this one, this one and these values of parts per million. Okay. So it's basically the same as what we did. Sorry ni tak ada. Basically the same as what we did last week. So step 3 is basically the steps yang start jadi lain lah sebab we have kalau step 3 dalam CC you have to draw the graph. Kalau step 3 dalam water cascade dalam betul lah water cascade you basically have to do your table. So you should have this table in your lecture notes. But basically what we need to know is what to put inside the table kan. So first things first kita ada K. So K ni sama je macam kita punya interval in our PTA. So it's just 1, 2, 3, 4, 5. Depends on how much intervals that you have. CK ni pula is your concentration levels for all the water sources and demand. So itu adalah concentration daripada lowest to highest kan. So it must be in ascending order. So yang tu memang kena ingat So basically it's all these values. So dia akan jadi 0, 10, 14, 25, 34. Okay. Sorry. Okay. So delta CK sama macam PTA juga is the difference between these values. So kenapa dia CK? So usually yang ni kan I, ni J, dia terbalik. Yang ni J, yang ni I. So IJK lah. So K is for both. So it considers both. So CK is the interval, is the change in your concentration with each interval. So kat sini is basically 10 tolak 0. So sini 10. Ni 14 tolak 10, you dapat 4. Ni 25 tolak 14, so you dapat 11. 34 tolak 25, so you get 9. Okay. Okay, sampai situ okay?
Okay, Doktor.
Okay.
Yeah. Alright, thank you for your response. So next is your FJ. So J is the sink. So F is flow rate. So remember it's a flow rate of your water sink. So you always have to fill it based on the concentration. Okay, so kalau kosong berapa dia punya flow rate? At 0 concentration, what is the water demand flow rate? Berapa? Betul. Betul. So at 0 it's 1.2. So apa yang we look at is just basically this value lah. Okay, what about 10? Exactly. Thank you. So 5.8. What about 14? So jangan tertipu So because it's your water demand, so it's for J. So because it's for J, you basically know that there is no flow rate for 14. So these parts kita biar kosong. So remember, we have to look at the next one pula, which is your flow rate for your water source. So kalau flow rate for your water source, untuk kosong berapa?
0.8.
Yes. What about 10?
Tak ada.
Tak ada. Okay. So ni apa kadang-kadang kalau kita salah dia jadi careless lah. So sayang lah kalau we careless benda yang simple kan. So always look at what is required kat sini lah. So kalau 14 you get 5.0. 25 you get 5.9 and 34 you would get 1.4. Okay. Boleh? Faham sampai
Boleh.
situ? Boleh? Alright, thank you for the response. Okay, cool. So this one is now your Fi minus Fj. So as it means, it's basically this tolak ni. So kalau kat value kat sini dapat berapa? So it's your demand minus your source. So for 0 berapa?
Negative 0.4.
Negative 0.4. Okay. What about for 10?
Negative 5.8.
Negative 5.8. So very important to remember that it has negative sebab dia adalah Fi minus Fj. So yang the rest is just basically salin
The
balik lah
same.
kan. Exactly. Thank you. Okay. For the response. For the interaction actually. Okay, so daripada situ kita dah boleh buat kita punya first cascade. So F cascade is the flow rate cascade. So it depends on the difference lah. So nama pun cascade. So you'll be adding it up. So you start with 0, tambah dengan 0.4, negatif 0.4 dapat negatif 0.4, tambah dengan 5, negatif 5.8 dapat
Negative 6.2.
negatif 6.2. Tambah dengan 5,
Negative 1.2.
negatif 1.2. Tambah dengan 5.9,
4.7.
4.7. And lastly, tambah dengan 1.4,
6.1.
6.1. Okay, so that is your cascade. Sama je macam kita buat your PTA. Just remember negative positive tu effect lah. So kalau kita salah kira tu dia akan effect juga. So now is your delta M. Macam mana dapat delta M? Delta M equals to
F time delta C.
betul. So it's F times your delta C. So it will be this value. So it will be your this value. So you tengok line ni. It will be 10 times. So this is your delta C. This is your F. Okay, so dia akan darab kat sini. Sebab tu dia ada jarak. So daripada sini kita boleh calculate. So 10 times negative 0.4.
Negative 4.
Negative 4. Okay. 4 times negative 6.2.
Negative 24.8.
Negative 24.8. 11 times negative 1.2.
Negative 13.2.
Negative 13.2. And lastly, 9 times 4.7.
42.3.
42.3. Okay, thank you everyone. So dapat daripada situ, kita boleh sekarang buat kita punya M cascade. So start from 0 again. Jauh tak nampak kan? So start from 0 again. Plus with negative 4.
Negative 4.
Negative 4 plus with negative 24.8. 28.8 kan? Plus with negative 13.2.
42. Negative 42.
Allah. Sorry. Jatuh. Negative 42. Rosak dah. Tak bijak. Okay, selamat. Negative. Oh no. I think I broke my
Macam salah kan?
Itulah. Rosak dah. I hope I didn't break my pencil. Okay, anyway, let's let that there. Okay, so negative, so you dapat negative 42 and then last one is plus with 42.3.
1.2.
Betul ke?
Salah.
0.3.
0.3, betul. Okay, so you get to isi all that. And then lastly is your delta M minus your delta M cascade divided by your CK. So basically it's going to be based on Oh, okay, boleh. So saya kena try pakai jari jap. Okay, so basically this value here would be this value here that divided by your CK. So CK yang ni lah. So it's basically this value dengan this value sini. Okay, so again it's at the same line supaya kita tak confuse kan. And ni tadi korang sempat salin kan, siapa yang salin. So dari situ you just bahagi and you get the value here. Boleh kira ke? Pencil saya dah problem.
Boleh.
Okay, boleh So you can calculate it, divide it and then you can get. I'm so sad. Tak sangka dia boleh rosak.
Doktor punya Apple Pencil tu yang second gen tu ke?
Kalau jatuh memang rosak.
Dah doktor. Tak tahu sebab doktor ke turn off screen dulu, connect, lepas tu buka balik, try tulis dekat notes tengok.
Macam ni? Kena turn off screen?
Turn off screen, lepas tu connect and then try tulis dekat notes.
Okay, turn off screen. Lepas tu connect. Thank you, sedih. Set. Okay.
Selalunya sebab bugs tu dia jadi macam tu.
Sebab bug, oh ya ke? Nervous dah? Set. Okay, let's try. Bismillahirrahmanirrahim. Let's hope this works. Tak boleh lah.
Tak boleh.
Terjatuh. Ke dia kena buka apa-apa tak ada?
Tak ada.
Tak payah buka apa. Tapi dia boleh connect. Okay,
Aigo, melayang 800.
Itulah pasal.
Sebab
Just
iPad
because
saya
dia
macam tu juga.
Kadang-kadang
Dia
dia
selalu
macam tu
tak. Kadang-kadang macam tu je.
Oh, first time. Nangis juga lah. Nak kena beli baru. I hope not. Okay, let's try this again. Dekat. Tak boleh lah. Macam mana? Tapi dia charging. Okay, I don't know how to do this. Okay. Oh,
Tu dekat.
Bismillahirrahmanirrahim. Kenapa?
Dia punya tip. Kejap tak doktor?
Dia punya tip apa?
Tip pensel tu. Kejap tak?
Apa maksud dia?
Ketat ke tak?
Oh, okay, sorry. Okay, cuba ketatkan. Bismillahirrahmanirrahim. Tak boleh.
Tak boleh juga.
Okay, kita biar dia bernafas dulu kat sini. Okay, tak apa. Kita doa yang terbaik. Ujian betul. Okay, anyway. So, you basically got this value here. And I'll try to use my finger and see if it works. So, basically kita dah dapat semua value tadi. So, kita dah dapat your highest. I think disebabkan saya tak ada pencil. So, let's try to work with this instead. And bear with me, I'm sorry. Banyak tu ujian lately. Semua pula dah tak respon. Why? Ke kena off on balik ni? Kejap Much. Okay. Let's try to do this. Okay, so tadi dah sampai sini kan. So when you do the cascade, saya tak share screen punya. Okay, so when you do that cascade, kita akan dapat the highest negative value. So this highest negative value would be your starting untuk your second cascade. So daripada situ kita boleh start buat kita punya next cascade. So remember sama macam PTA, you're going to start with that FFW. So that fresh water. So it will become your, dia akan jadi fresh water flow rate lah sebenarnya, tapi you just start with that value sama macam QH min kita buat sebelum ni. Tambah dengan negative 0.4 you get the values and then you tambah again. So you do the next cascade sampai you dapat that last value. So this 8.157. And after that, you have to calculate your delta M again, which is, remember, delta M equals to F cascade times CK, delta CK. So it will be this pink yang saya highlight pink ni, you darabkan, and then you get your delta M pula. So lepas tu you do your delta M cascade. So macam mana kita buat pinch untuk heat, you get the same thing. So you get a pinch point, which is a 0 point. And obviously the first value would be your freshwater flow rate, and then your last value would be your wastewater flow rate. Boleh follow ke?
Boleh Doktor?
Boleh. So nanti boleh try it out so that you can actually try to do the calculations by one. So ini yang tadi lah. So you dapat freshwater flow rate, you punya wastewater flow rate and your pinch point. Okay. So that is basically the end of the cascade lah. So kalau perasan dia calculate dah siap dah kan. So dia very easy lah to do. So daripada situ dia kejap boleh why? Okay, tak apa. I'll try to do that. Okay, so untuk the last part here is going to be a water network design. So shall we take like a 5 minutes break and hopefully I can figure out macam mana nak do this pencil to get it working, because I think best jugalah kalau ada boleh annotate. Boleh ke?
Boleh Doktor.
Okay, so we'll start back in 5 minutes lah. Thank you very much everyone for your patience.
Thank you Doktor.
Okay, never mind. I couldn't figure it out, but I'll try to do that later lah kot after class. So apa, we'll try to deal with having to use my finger. See how that works. So okay, boleh ke kita start?
Boleh Doktor?
Okay, cool. Thank you very much for everyone's patience. For part 3, basically macam mana our heat, we have our QC min QHB, lepas kita dapat dia punya target, we usually have to do the network design. So the heat exchanger network design looks at how to use specific heat in the hot stream or specific basically coldness, basically releasing heat, and so nak sejukkan the hot streams in the cold streams. We want to match them together. Macam tu juga kita nak cuba matchkan air yang perlukan air yang probably sedikit kotor. So we want to try to supply that water towards that respective demand accordingly. So we want to understand how you want to do it. So there's basic rules. Kalau macam heat, kita ada CP rule, kita ada all this, you have the golden rules as well. Basically, one of the rules untuk water network design is you always have to feed the cleanest demand with the cleanest water source. So that's why kalau you guys perasan, kita memang susun ikut ascending order. So we would have to arrange from the cleanest water first. Okay. We have basically constraints untuk network design, and it depends usually on the flow rate or concentration lah kalau untuk demand. Tapi kalau untuk flow sources, usually it's just the flow rate sebab dia adalah output dia. Okay. You always have to arrange according to concentration. So this is the same thing, ascending concentration. So S is usually supply, D is demand. Kita kena dapat dia punya fresh water flow rate and your wastewater flow rate from your water targeting. And we basically have to satisfy the entire material balance. So kalau it does not satisfy, means jawapan kita salah lah. So similar to macam mana PTA ataupun dalam heat energy, kita boleh check kita punya energy punya pinch, kita boleh check everything afterwards. Sama juga dengan water. So mana golden rule dia? Okay. So basically this is the steps to do the water network design. So if you realize from steps 1 until steps 3, so steps 1 sampai step 3 ni, we already did in our last week's class as well as tadi kan. So kita dah dapat identify mana water demand, mana water source. Kita dapat arrange guna concentration level in ascending order. Lepas tu kita guna water CC ataupun water cascade untuk dapat FFW dengan FWW. So tu dah settle. So sekarang ni we want to know how to do the water network, water design network. Okay. Oh, kalau pakai jari tak boleh nak. Next. How do you turn next? Okay. Anyway, so this is an example of the question. So dia kata kat sini, if you realize dia tak bagi PFD. So you already don't have the data extracted. So you don't have to extract it. But if you have to extract it, you have to find sama macam hari itulah, which is the equipment yang perlukan water sources for it to function. Okay. So dia kata kat sini the fresh water flow rate. So dia dah bagi your fresh water flow rate, which is your 70 kg per second. And boleh pakai ni. So which is 70 kg per second with a ratio of 30, 35 and 5, and wastewater flow rate, so how much water that needs to be clean, which is 50 kg per second. Okay, and dia dah bagi tahu berapa demand dia apa, flow rate dia, and concentration dia, sama juga source dia apa, flow rate dia and concentration dia. So first thing is kita kena complete data. So apa yang tak ada kat sini? So kalau heat, we have delta H equals to CP delta T. So kalau ni apa yang kita tak ada?
Delta M ke?
Betul. So remember the equation is delta M equals to tak boleh juga. Okay, delta M equals to F delta C. Okay. So kita basically calculate your delta M based on dia punya F times your delta C. So you just calculate lah 50 times 20, so 50. 50 darab 20 dapat 1000 and 100 darab 50 dapat 5000. So you calculate semua ni and you dapat dia punya delta M and you write down the information that you have. Okay, daripada situ kita dah complete dah data kita. So dah settle lah step 1, 2, 3. So you want to start with step 4. So arranging the water demands and sources according to dia punya increasing concentration. So actually basically you have to have your demands on top. So atas ni demand and dekat kiri ni is your source. Okay. So you punya demand ni you would have your F Allah. You would have your F, C and delta M dekat sebelah dia sebab those are the information that you need. So D1 for demand 1, D2 is for demand 2, D3 and D4. So salin je lah balik 50, 20, 1000. So you buat semua untuk demand and your sources. Okay ke sampai sini?
Okay, Doktor.
Okay, Doktor.
Right, thank you for the response. So lepas kita dah arrange, we want to start to distribute your freshwater flow rate. So kalau untuk heat, biasanya QC ni QH ni kita akan buat last. Tapi untuk untuk water pinch, kita akan buat first. So we have to distribute dia punya water flow rate. So basically kita distribute water flow rate tu based on what is given lah. So dia kata kat sini dia bagi 70 kilogram per second of your water kan. So dia ada ratio 30, 35 and 5. So it means 30 to the first one, 35 to the second one and 5 to the third one. So sebab tu dia dapat kat sini 30 kg per second. 30 kg per second, 35 kg per second and last one is 5 kg per second. Okay. So kalau soalan tu dia tak bagi ratio, then you can do it yourself lah. You can just easily do macam let's say 50 to the first one ke. So you can play around with it lah. Usually dia akan bagilah kalau dia nak bagi. Kalau tak, you can just macam kalau macam ni, if it were me, I would macam terus bagilah 50 kat first one and 20 dekat the second one D2 because it's 70 kan. So you usually just feed the first demand with the maximum that it can achieve lah. Tapi kalau kita nampak kat sini, dia punya D1 pun it can be a bit dirty. So if we understand what this actually means, it's the demand, it means that it requires 50 kilogram per second of water at a concentration of 20 and the amount of dirtiness that it can accept is 1000. So dia tak adalah perlukan 100% clean water. So macam tadi kita ada boiler kan. So boiler feed water, it must have 0 ppm. So it must require 100% clean water. So kalau macam tu memang kena guna fresh water je lah. So tak boleh ada recycle, tak boleh guna daripada source. Okay, so lepas kita dah allocate kita punya fresh water, we want to now distribute kita punya sources to those fresh water, to those demand. So this is going to be a bit hard using my finger, but let's hopefully kita cuba kan. So this is the step 6. So kalau step 6, basically sekarang ni kat sini kita perlukan 50 kan. So kita dah bagi 30. Berapa banyak yang kita masih perlukan?
20.
20 kan. So kita nak dapat dari mana 20 kg per second tu? Daripada sini lah kan? Betul tak? Allah. Kenapa hilang? Daripada sini lah kan? So basically we can basically get it from our first source. So remember we need another 20 kilogram per second of water. So kita perlu lagi 20. So remember delta M. Okay, this is very not friendly. So delta M equals to F delta C. So sekarang ni delta C kita tahu dia punya limit is 1000. Okay. So daripada dia punya limit, we can calculate how much flow rate that can actually be supplied. Ataupun other way around lah, you can also calculate how much kekotoran yang ada. So what you do is you take that 1000, you divide it with your concentration kat sini. So kalau 1000 divide by 50, macam tu. Kalau 1000 divide by 50?
20.
20. So basically it means, and remember your delta, your F equals to M, your delta M equals to F delta Cn. So when you get, guna yang ni lah senang. So basically when you get that 20 tu adalah kilogram per second. So it's the amount of flow rate to supply to D1. Okay. So daripada situ, kita tahu dia punya M, and then you can just times 20 times your 50. So you get the delta M, which is 1000. So daripada 1000 tu, kita boleh tahu yang dia akan satisfy kita punya tahap kekotoran kat sini. So your mass load limit at D1. Okay. So daripada situ, dah settle belum D1 ni? Cukup tak 50? Cukup. Dah kan? Cukup kan?
Dah.
So because you have 30 dekat sini, 30 from your fresh water. Tunjuk pun dah tak boleh. 30 dekat your fresh water and then your 20 dekat your S1. Tapi S1 ni kita ada lagi tak?
Ada.
Ada lagi kan? So what we do is kita supply to our D2. So daripada situ kita remember tengok D2 kita ada 35 fresh water coming in. And then you have, so you have 35 fresh water coming in. And then you have, so kita tahu daripada sini kita dah tolak 20. So kita ada an extra 30, right? So let's try to see, kita letak 5000, which is your MD2. Delta MD2 divided with the concentration of your S1. So concentration dekat sini. Divided with your 50, you would get 100. So 1000 ke 100?
100.
Okay. So 100 ni is your flow rate. Okay. So we only need for the F yang tinggal at S1 is only 20 kan. So kita hanya ada, so for D2 to be satisfied, we require another 100 lah. We require a total of banyak lah lagi yang diperlukan kan. Tapi sebenarnya sekarang ni kita dah ada 35 and yang tinggal kat S1 ni hanya tinggal 30. So that's why you take 50 minus your 20, which is the one supplied to your D1. So you get 30 kat sini. And you use your 30 to times your 50, which leaves you with a delta M of 1500. So sekarang ni kita boleh ambil daripada S1 provided give to D2 1500. Tapi sekarang ni dia tak match delta M ni dengan delta M ni, tak apa ke? This delta M which is 5000 dengan this delta M which is 1500. Boleh ke? Rasa-rasa boleh ke tak boleh?
Tak boleh.
Kenapa tak boleh? What does delta M mean? So delta M means the amount of particles that can be in your water for it to accept. So di tahap kekotoran air lah, in easy words kan. So D2 can accept a dirtiness of delta M equals to 5000. Okay, which is milligram per second. Tapi sekarang ni kita bagi dia 1500. Boleh ke tak boleh?
Boleh lah.
Boleh lah kan, yes. That's correct. So because it's cleaner than it actually is, can be accepted. Sebab, so remember dia tak semestinya, oh dia kena 5000 baru dia boleh masuk kan. And kalau kita fikir balik, another thing is, we only baru ada 35, baru ada 35 tambah 30 kan. So baru 65. So we're still having, kita masih ada remaining water that needs to be introduced into the demand. So where do we get it from? Tak cukup lagi kan 100. Mana kita nak dapat lagi? S1 ni dah habis.
S2.
Yes. So kita akan ambil S2. Kita akan jalankan dekat D2. So you do the same thing. Yang tinggal. So you require. So 35 plus 30 is baru. 35 plus 30 is baru 65. 65. So you require another
35.
Yep. So you require 35 from your S2. So you basically take 35 times with 100, which is your concentration. Kita akan dapat delta N berapa?
3,500.
Okay. So 3,500 tambah dengan 1,500 dapat berapa?
5,000.
5,000. So complete tak kita punya D2?
Dah.
Dah complete kan? Yes. So this is basically what it will end up being. And you have to do it satu-satu. I'm so sorry I don't have a pencil. It's really hard for me to show. Tapi you can try to do it on your own and you will end up getting so you akan letak the S2 tadi, yang remaining. Tadi macam tadi kita tengok kan, kita letak 35 kat sini, so you dapat 5,000. And then selebihnya, so 100 minus 35 is 65. So again 65 ni akan direct dengan concentration, which gives you your delta M. And then you tengok dia punya FFW dia bagi 5 je. So 75 minus 65 you still need 10. So 10 ni akan ambil daripada S3 and then dia akan pergi ke D3. And then again the remaining of the S3 you would put into your D4. And lastly you punya S4 akan pergi ke D4. So basically dia just banyak kira-kira lah. But if you faham the concept, it should be fairly straightforward. So you always have to check balik whether kita punya source and demand punya delta M balance up lah. So kalau dia lebih daripada the amount of your demand that can be accepted. So contoh kalau kat sini tadi kita kira-kira kan, dia punya delta M sini 6,000. So that means something's wrong. So if we get something like that means kita kena tukar lah ataupun we have to supply more fresh water. Okay, that's one thing. And last, also the next thing kita kena check is kita punya wastewater, kita punya wastewater kat sini. Kenapa? Dia punya wastewater kat sini must be the same with what we have calculated in our cascade ataupun kita punya CC. Okay. Boleh faham ke?
Faham, Doktor?
Faham kan? Cuma you have to try it out lah kot because it might take some time untuk kita try calculate it. When you calculate yourself, it will be a lot easier lah for you to grasp it. So is there any questions up to this point? Yes, no?
So far no, Doctor.
So far no Okay, thank you for the response. So kalau tak ada soalan, my question to you. What happens kalau kita violate first rule ni tadi? So water network design, dia punya rule simple je. You have to feed your demand, your cleanest demand with your cleanest water source. Apa jadi kalau kita violate this law? This rule, sorry. So instead of kita letak S2, S1 dekat sini, kita letak S2 kat atas. Apa jadi? So kita tak ikut ascending order concentration ni.
Boleh kot kalau delta M dia larger.
So at some point kita akan kira boleh. Tapi what happens is, so you can try this out. So kalau saya letak S2 dekat sini, kita boleh kira kan. So bila kita calculate kat sini, you will see dia punya delta M kat sini dah 1,000. Tapi dia baru dapat 10 saja. So kalau dia dapat 10 je, dia punya limit dah sampai, you have to supply the rest of the 40 sebab dia perlukan 50. So dia perlukan 50. So yang S2 hanya boleh bagi 10 je. So basically kita tak boleh lah kan sebab you cannot accept anymore dirtiness. Dia dah sampai maksimum tahap kekotoran dia. So you have to supply the rest 40 using fresh water. So and if you do the same for D2, you can see you require the same thing lah. So basically it would result with a higher utility. So it will cost you more lah basically. So dia akan jadi lagi mahal. And dia jadi tak bagus lah. Sebab tu kita kena always susun ikut ascending order of your concentration. Okay, faham ke?
Faham, Doktor.
Faham Okay, thank you very much. So this is an exercise daripada yang hari tu punya. Dan ini senang lah sebab dia hanya ada 2 demand dan 4 source. So try to do it out and it's a lot easier lah compared to the example yang kita tengok hari ni. So try that out and kita boleh cuba tengok dapat tak buat water recovery network. Okay. So basically from today's lecture, we see macam mana nak buat water cascade, and it's obviously easier lah. Especially kalau kita ada more ataupun a larger problem. If you have more data, you can just put it in Excel and then you tolong calculate and then you can do your water network untuk tengok macam mana kita nak supply water dirty water to clean to sources that require that can accept a bit of dirtiness in the water. So we also see what happens when we actually violate our water network design. So it will basically lead to an increase in utility, meaning the cost will be more lah. So that is basically all for today's lecture. I apologize for the hiccups and technical difficulties, and thank you for your patience. Do you have any questions before kita end our class?
No, Doctor.
No. Thank you for the response. Okay, so kalau tak ada soalan, I guess insyaAllah kita tangguh kelas kita dengan tasbih kafarah and surah Al-As. I guess that will be the